All right, so today we're going to continue with trigonometry, day 4. And the only difference today is that we're going to have to set up our own diagrams, but otherwise it's the same type of problems that you did yesterday. So there's 2 vocabulary words that you need to know. So we are on page 18 in your trig booklet. This is day 4 notes, so angle of elevation and angle of depression. Angle of elevation is from the ground to the diagonal. So if you're looking at like this drawing, you've got, here's the ground. The ground to the diagonal creates this angle. So this is our angle of elevation. Think of elevation like elevator goes up. So it's from the ground up. Angle of depression is from the horizon to the diagonal. So it's like an imaginary line in the sky that's parallel to the ground. So if we remember our symbols from geometry, these tell us that these are parallel. This is our horizon. And the nice thing about remembering parallel lines in geometry is if you have 2 parallel lines that are cut by a transversal, this is our transversal, then alternate interior angles are congruent. So this angle theta is actually the same measure as that angle theta. So if we knew that the angle of elevation was 25 degrees, then we would also know that the angle of depression would also be 25 degrees. So sometimes it's easier if they give you an angle of depression just to put it down as your angle of elevation because it's the same amount. And then just use this triangle that you have drawn. Okay? So the other thing you're going to have to do is solve problems. So you can pause the video if this is too fast for you, but we're going to go through these steps when we do the problems on the next page. All right, so first thing we're going to do is we're going to draw and label our diagram. So you can be as creative as you'd like to when you do your diagrams. You could draw pictures, you could just draw a generic triangle, whatever you want to do. Then you're going to label the opposite, adjacent, and hypotenuse side. You're going to set up an equation using SOHCAHTOA, meaning you're either going to do sine, cosine, or tangent. Then you're going to solve for x. And then because we have a word problem, we're going to answer in a complete sentence. All right, so pause the video if that was too fast for you to write that down, and then we're going to do these 3 problems together. All right, so problem number 1 says a cell phone tower casts a 22-foot shadow when the sun is at an angle of 48 degrees with the ground. What is the height of the tower? All right, so step 1 is to draw and label a diagram. Okay, so we know we're going to have some kind of a right triangle. A cell phone tower is going to be sticking in the ground and it's going to go vertically. So this is my cell phone tower. Okay, here's the ground. And it says that it casts a 22-foot shadow. So if you think about it, where is your shadow? Your shadow is always going to be on the ground. If the sun is, let's say, over here, right? Your shadow's on the ground. Make sure that you always draw your shadow on the ground. Your shadow's not the diagonal. It's not vertically up here. So here's my shadow. And we know that this is 22 feet. All right, next thing is the sun is at an angle of 48 degrees with the ground. This is also known as our angle of elevation. So my 48 degrees from the ground up, I'm going to put that here. I'm going to label it at 48 degrees, and I'm also going to put theta because that's our reference angle. All right, what is the height of the tower? So this is what you're trying to find. Since we don't know that, that's x. All right, so step 1, draw and label a diagram. Step 2, label opposite, adjacent, and hypotenuse. So from here, I'm going to look at where is opposite, directly across from the 48. Where is adjacent? It means next to. And hypotenuse is your diagonal across from the 90 degrees. All right, so how are we going to set up our equation? Look at the ones that have values labeled in them. So we have 22 and x. These have labels. This hypotenuse has no labeling, so we're going to cover that up. We need to look at opposite and adjacent. So for step 3, set up an equation with SO, CA, or TOA. Well, which one has opposite and adjacent? I need the one that has O and A, so that's tangent. That tells me I'm going to set up tangent of theta is equal to opposite over adjacent, and I'm just going to fill in anything I know. So tangent, do I know the angle? Yes, that's 48 degrees. Opposite is x, and adjacent is 22. Okay, so now you need to solve for x. How would we get x by itself? Well, if I want to undo my divide by 22, I want to multiply by 22. So I could do that. I get x equals, and then this thing I'm going to put in my calculator. So find your calculator. Again, always make sure you're in degree mode. Okay, so now I'm going to do 22 times tangent of 48. And then I'm just going to round to 2 decimal places, so my answer is 24.43. All right, and then the final step is to answer in a complete sentence. So make sure that you actually say what that 24.43 represents. It says, what is the height of the tower? The height of the tower is 24.43, and since these were measured in feet, then I think that my cell phone tower should also be measured in feet. So if your shadow is in feet, then your cell phone tower is in feet. All right, we're going to do 2 more problems like this, following the same procedure. All right, a builder is constructing a wheelchair ramp from the ground to a deck with a height of 18 inches. So if you're trying to go up a wheelchair ramp, here's your ramp. That's your diagonal. The ground is here, and the person on the wheelchair is trying to get up to a deck that's up here. Right, so the height is 18 inches. That's your vertical amount. Here's your right angle. The angle of elevation, so that's from the ground up, between the ground and the ramp, must be 4.8 degrees. What should the length of the ramp be? So which one was our ramp? It's not the part on the ground. Here's our ramp. So that's what we're looking for. That's the part we're trying to find, so that's what we're going to call our x. What's the length of the ramp? All right, so step 2 is label opposite, adjacent, and hypotenuse. So here's my angle. This is opposite. Ground is adjacent, and hypotenuse is over here. All right, for step 3, when I want to set up my equation with SO, CA, or TOA, I need to look at the ones that have actual values. So I have an x and an 18. I've got opposite and hypotenuse. So think of SO, CA, TOA. What has O and H in it? That's sine. Sine of theta is equal to opposite over hypotenuse. Okay, so we have sine of 4.8 is equal to 18 over x. All right, so we're going to solve for x. The only difference is now you've got your x in the denominator. So I'm going to multiply by x on both sides first. That'll get rid of my x in the denominator. Then I've got x times sine of 4.8 equals 18. And then I want to get x by itself. These are being multiplied, so I need to divide both sides by sine of 4.8. That way my sine of 4.8 disappears. Okay, now this is what you put into your calculator. 18 divided by sine of 4.8. And you get 215.11. Okay, so there's my answer for x, but let's answer in a complete sentence. It asks, what should the length of the ramp be? The ramp should be 215.11, and since this was measured in inches, this is also inches long. All right, last problem, number 3. After a severe thunderstorm, Jimmy wants to see if there's any damage to the roof of his house. All right, so here's his house. If the roof is 65 feet high, so to get up to the roof, he's got to go up 65 feet, and the angle of elevation must be 37 degrees. What should be the length of the ladder? So for him to climb to the top of his house, he needs to lean a ladder against his house. All right, so you're always going to put your ladder on your diagonal, and the ladder goes from the ground up. Okay, so here's your ladder. Here's your house. There's your right angle, and it says the angle of elevation, that's from the ground up, that's 37 degrees. So I'm going to put theta right there. All right, what should be the length of the ladder? So that's what we're looking for. That's my x. All right, so next step is what is opposite, what's adjacent, and what's hypotenuse. So from here, here's your opposite. My adjacent is the ground, and my hypotenuse is across from my 90-degree angle. All right, so let's look at the ones that have numbers and variables in it. So we've got 65, and we've got an x. All right, so again, you look at what has opposite and hypotenuse in it. So that's, again, sine. Sine equals opposite over hypotenuse. So you're going to fill in sine 37 degrees equals 65 over x. All right, and then this is exactly the same as the last problem, so I'm going to multiply both sides by x. So I have x times sine of 37 is equal to 65. Then to undo my sine of 37, I want to divide my sine of 37. So I have x equals 65 divided by sine of 37. So I'm going to grab my calculator, do 65 divided by sine of 37. All right, and that gives me 108.01. All right, so now it says answer in a complete sentence. So the length of the ladder is 108.01, and this was measured in feet, so this must be feet. Well,